Welcome to another video, the same every time. GCSE Maths, looking at the questions that apart from the numbers are the same every time. Learn how to do them, get yourself into the marks, get yourself into the grades. We're looking at three-dimensional Pythagoras theorem and three-dimensional trigonometry. Now, this might be something that you might tend to avoid. If you see a question like this, you might think this is a high-end topic. Maybe if you don't think of yourself as a natural mathematician, this might be the kind of question that you would avoid and, try to find some easier questions on the paper. But that would be the wrong strategy. You need to get as many marks on the exam as you can, and for a question like this, you certainly can get yourself into the marks. Because a lot of what you do in these questions is the same every time. Let's have a look what we've got here. Exam question. The diagram shows a cube, A, B, C, D, E, F, G, H, they're the corners, the vertices, of edge 7 centimeters. So each edge of this cube is 7 centimeters long. Calculate the angle between AG and the base of the cube. Now, first of all, we need to ask ourselves, what are they asking us for here? So AG, if I see AG, two letters, then that basically means a straight line. So it's the line from A to G. There it is. So the line from that front left-hand corner, bottom corner, to the top right-hand corner at the back there. So calculating the angle between AG and the base, well, between the AG and the base, what do they mean? They actually mean the diagonal of the base. So it's that diagonal of the base. And then there we are. So we see we have a right-angled triangle here. That's 7, because that's just the edge from C to G. So A to G is the straight line, just from point A, corner A to corner G. And when they say the angle between AG and the base of the cube, they mean the diagonal line in the base. So the angle that they want is this angle just here. So can we find enough extra information to find that angle? I think we probably can. We have a right-angled triangle here, and to get an angle in a right-angled triangle, I just need 2 of the sides. I've got one of the sides already, that's the side 7, and if I can get another side, either A to G or A to C, then I will be able to find the angle. Right, the easiest side to find is the side from A to C. So imagine that we're looking at the base of this cuboid, or this cube, so A, B, C, D, and I'm thinking that I want to find from A to C just there. That would be 7, that would be 7. Because this is a cube, that's a right angle. And I just want to find the length of that side there. Now, in my right-angled triangle, if I look at this as being a right-angled triangle, half of a square, I'm finding the longest side, the side opposite the right angle. Now, remember how we do this from the Pythagoras theorem videos? Square, square, add, square root. So 7 squared plus 7 squared, square rooted, and that will give us 9.899494. Right, so that is the length from A to C, which is 9.899494. Right, it's worth saying at this point that in this kind of question, a three-dimensional trigonometry question, three-dimensional Pythagoras theorem, even if you have absolutely no idea how to answer the question, your first move should always be to find the length of the diagonal of the base, in this case the ABCD side. Find the length of the diagonal of the base, because usually that's going to be something that you will need to use in the question. So even if you can't go any further, even if you can't get to the end of the question, you're in the method marks. So I want to find this angle just here, and if I have my right angle triangle, there's my right angle, here's my right angle triangle. This side would be the opposite, that side would be the adjacent. So O and A, we're dealing with tan, so inverse tan to find an angle, O divided by A, 7 divided by 9.899494. That answer should still be on your calculator screen, so you can just use the answer function on your calculator. So inverse tan of 7 over ants, and I've got 35.3 degrees. I'll give that to 1 decimal place. There you go, that's the end of the question. Not as bad as it looks. The trick with these three-dimensional trigonometry, three-dimensional Pythagoras questions, is to look for the two-dimensional right-angle triangles inside the question. And of course, your first move, if you even can't think of doing anything else, find the length of the diagonal of the base. Well, I hope that one was useful to you. If it was, then like and subscribe. Thank you very much for watching. I will be back in the next video.